And welcome back. We are now going to dive into looking at string methods. Now this is going to be a little bit lengthier of a lesson. Now it's not going to cover every method that exists within the string class, but we are of course going to look at a few of the more common ones that we're probably going to see as we start moving forward into our programming journey. So first thing to start us off with is strings are a class object. Now you may not be as familiar with these kind of terminologies, but that's okay. But if you recall, we said that strings are not a primitive type like int or double. Instead, they're what known as a class type. In Java, these are not a primitive type. They are actually a class type that is a class, and there's a reason for why Java handles them this way. So in Java, even though we have all these different structures, such as classes and stuff like that, I don't want you to worry about them right now because we will look at them more in depth later. However, there's some terminologies I want you to start getting familiar with because you're going to start hearing them kind of start popping up more and more as we dive deeper into the course. The first, of course, is that of a class. Well, class is simply just a name for the type whose values are objects. So string is the name of the class that's in Java. As we get further in, you'll see other classes, and their name is simply going to be whatever we're calling it. So again, string is just the name of the class. Now, an object is simply just some entity that can store data and then take actions. All right. Any string we create is therefore an object. It's an object that exists in Java. It's a class object. And lastly, we have methods. These are actions that that object can take. All right. We're going to look at actions later on, such as the length method and stuff like that as we dive in here. But I want you to get familiar with these terms first. The easiest way to kind of think about this, if you're having a hard time about it, just think about a box. If we have a box, that's like an object, right? And with the box, I can do different actions, such as find things like length, width, height, volume, surface area. Those would be more like our methods that we're going to end up using here. All right, so introducing methods. Let's go ahead and dive right into our very first method. Get our hands dirty with a very easy one to wrap our mind around, which is, of course, going to be the length method. But again, remember that actions that an object can take are those methods. So with the string class, we have multiple methods that can occur. And again, we're not going to look at every single method that exists for the string class. But we're going to use the length method because it's a real easy one to start off with here. So I have a string greeting, and I'm setting it equal to hello with an exclamation point. All right, and you notice the quotations, remember, are indicating to Java the beginning and the ending of the string. If I were to say greeting.length, what do you think that string would produce a value of? How long would you guess that string is? Well, the first thing you need to know is that dot piece there, so greeting.length, is simply just a clue to Java to tell it, hey, I need you to invoke or to call that method. So anytime you're seeing a decimal point like that, anytime you're seeing a period, that's simply just meaning, hey, we're going to be using a method call to say, what do we want this object to do next? So often we want to see a value displayed though. One thing you want to keep in mind is that we're going to need to place inside a systemout.println. So systemout.println hello.length. And we're going to talk about and we're going to see why this happens if we don't do this. But if we want to see these values, that's why they're going to do. You don't always have to have it inside of a println statement. It's only if we're expecting to print out a certain value. If we just want to run the method and have it do its thing in the background, we don't need a println statement. But for what we're starting off with, the println statement is probably going to be used for most of our actions. All right, so looking at string.length again with a little bit more detail. Remember, it's simply just going to return for us the number of characters within a string. In our example, we had string greeting equals, quote, hello with an exclamation point, end quote. System.println, greeting.length. And notice again, I put this in a system.println because if I just say greeting.length, it's going to run, but we won't see what that value is. So by putting it inside of a println statement in that console when I run that Eclipse, I will see what that value is. And of course, that value would just be 6 because remember, the exclamation point, even though it's not a letter, it is still a character within the string. So remember, characters by definition are numbers, letters, characters, pretty much anything that's on your keyboard, including spaces. Now, if I wanted to use that value of length in a variable, and this is where having these can come in handy, I could say something like string farewell equals goodbye. And then I could store that, for example, in an integer. So int count equals farewell.length. And now you can start seeing where having it into a variable could become handy because I can say system.println, the length of the string is count. And so by having it where we don't necessarily have to have it in a print line statement, you can start seeing where some of this value comes into by being able to plug it into different variables and stuff like that. But again, this is just one method that we're going to look at. We have the equals method here, which is of course just simply going to go ahead and test for equality. All right, whether or not something is equal. And the nice thing about this method is simply going to return something whether it is true or whether or not it is false. So let's take a look at a couple examples. Here I have string greeting is equal to, quote, hello. Greeting.equals hello will return true. Greeting.equals goodbye will return false. Greeting.equals hello will also return false. Now, if you look at that, it might be a little interesting because you say, wait, this is hello and this is hello. Well, it's because how Java works here. So we're comparing, of course, two string objects, all right? And this is another example just for us to look at kind of side by side. It's the same things we're seeing up here, but here we're putting it inside of a print line statement, all right? So here we say hello, we say goodbye, we say greeting equals another string. So greeting, of course, we saw up here was hello. Another string, of course, is being goodbye, much as you saw here. We would expect this one to print out false. Now, in this example, as I had mentioned, these are not the same. All right, and if you haven't figured out the reason why, I'm going to let you in a little clue here. All right, notice that the cases in these do not match. All right, so if our original string had an uppercase H, but then this new string has a lowercase h, because those cases don't match, it's going to come back as false because it says those aren't the same thing. All right, but there's got to be a way around this, right? There's got to be a way for us to say, well, they're pretty much the same word. And there are times we don't want things to be exactly the same, and that's where equals can come in real handy. But then we also have equals ignore case. All right, if our case value doesn't matter for any kind of testing purposes, there's a method that allows us to ignore casing. All right, so let's just say we have the user want them to type the word yes. All right, if they type all lowercase yes, all right, or they type all uppercase yes, ultimately we want those to be the same thing. So for example, the word yes is typed, but the user is saying, hey, I want to type with a capital Y. We want these to effectively be the same thing. Ignore case is going to be a way for us to test that. So it returns true if the values of the strings are equal, and it's going to ignore upper and lower cases. So in this example, I have string name Mary with an exclamation point. System.println name.equals ignore case Mary. You'll notice they're the exact same thing, except this one has an uppercase M, this one has a lowercase m. This one would return true because, again, they are the same thing, ignoring case. Now, if I were to, for example, add another space in here or an exclamation point or anything like that, or change the spelling, then equals ignore case would still come back as false because they are not the same string. All right, and as I already mentioned, this is a returned value of true. Now, let's say we wanted to look at, we saw how ignore case works, but what if we want to avoid casing issues altogether? All right, we want to say, you know what, I'm not worried about it. And there are times when it is very handy to take something and put it all in one case or another. And so we can convert a string from either a mixed set of casing to something that's either all lowercase or to all uppercase. Well, with the string.toLowercase, we are simply just returning a string with characters that are all to lowercase. String greeting goes, hi Mary, system.out.println, greeting.toLowercase. This one's simply just going to come back as hi Mary, but if you notice, it's in all lowercase. If we want to convert a string now, so this is, let's say we want to make this change permanent, I'd have to do something like string sentence equals, this will be converted, sentence equals sentence.toLowercase. Because if I just say greeting.toLowercase right here, it will print out like this. But one thing I want to point out with toLowercase is we can actually make it permanent. We can actually do a permanent change to the string. So if I say sentence equals sentence.toLowercase, that will permanently make this sentence in all lowercase. Any of the uppercase letters that were there will be lost. So this does give us a little bit more power in some ways than using something like equals ignore case. And similarly, we have a string.toUppercase. All right, so it's going to function exactly the same as what we saw with the lowercase, except it's going to now make everything uppercase. So if we look at our hi Mary example here again, except now we're doing toUppercase, we're going to see it in all caps as hi Mary. And of course, if we want to convert that, it's going to function the exact same way. All right, so if I put this will be converted, sentence equals sentence.toUppercase, and of course, it will then convert that sentence into hi Mary, all uppercase, and it will stay as all uppercase. All right, now, what if we have a string, then we have those extra characters I talked about, like someone's typed in an extra space at the beginning, they hit the space bar, they put a space at the end, and all of a sudden, oh no, even though the word looks the same, it's not the same because there's extra spaces here. Well, there is a way for us to actually address this. All right, if they accidentally type that space at the beginning and the end, if we look at, are those strings equal? Well, technically no, because if you have an extra space, well, we know just by looking at the length method that one string is going to be longer than the other space, because technically a space is a character. Well, how do we get rid of those spaces? How can we take out those extra spaces that might be before or at the end? Well, the simple way to do this is use the string.trim method. So for example, if I look at this one, I have string pause equals, and you can see a bunch of spaces in here, and then more spaces at the end. If I go ahead and just print that out with the pause.trim here, it's simply just going to be And I could, of course, do this with a conversion. I could say like pause equals pause.trim, and it would then change the value of pause to be just without those leading or trailing spaces. So it's a pretty cool method here for us to be able to, if someone actually types in extra spaces, to kind of just clean up that string just a little bit. Now, before we move into our last couple of methods here, there is one thing I want to talk about, which is that of the position of values within strings. So when we look at strings here, this definitely applies a lot more when we get to later concepts of like arrays and lists, but based on how strings work, because they are really a collection of characters, it's very important to kind of start getting this idea in our head right now. All right, the first thing you need to know, if we look at the position of a string, that very first character is always considered to be at a value of 0. So it's always starting at 0. It doesn't start at 1. The first position is a value of 0. And this can be a little bit of a change for you to think about. All right, but if we look at this example, you'll see we have a total of 12 characters, but our values are going to go from 0 to 11. So we start counting at 0 instead of counting at 1. So in our phrase, Java is fun, you'll see, of course, our first position is at 0 and it goes up to 11. Additionally, you'll see that our spaces and our punctuation are counted as characters. Because remember, a space is indeed a character. So Java is fun, period. You'll notice we have 0 through 11. All right, that is our positions. But then the total characters are 12. So if I were to ask you what's the length of the string, you could tell me that it is 12. But if I were to ask you what's the position of the value at, let's say, 3, well, you'd say, well, at 3, it would be A. We wouldn't actually look here with 2, and we wouldn't go 1, 2, 3 and say, it's V. At 3, it's actually going to be A. So keep that in mind as we look at our last couple methods here. All right, string.char@, and this is why I wanted to make sure I pointed this out, because with the char@ method, this is going to be really helpful if we want to find the position of something within a string. So it returns the value of a character in that string. And remember, the count is going to start at 0, just like we mentioned, and then it goes 1, 2, and so forth. So if I say string greeting goes hello, and I want to print out the value of char@0 and the char@1, because you can pick any value that you want to print out, we're going to print out the values of H, and we're going to print out the value of E. All right, because again, remember the string is starting at 0. It's not going to start at 1. So again, this is going to be something people who are first starting to program and working with strings can have a little bit of difficulty with. So I just want to stress this a lot. Now, right now, this might seem a little weird, but it's going to make a lot more sense and have a lot more practicality when we start using loops or branching statements to look for specific characters within our strings. Now, the next thing is the substring method. And the substring is a kind of a cool little method that we can work with. What if we only wanted, let's say, a portion of that string? I don't want the whole string. Let's just say the string's like 1,000 characters. And let's just say we only want, let's say, the first 5 characters out of that string. Well, we can use substring to return a portion of the string, starting at the value defined. So let's say 0, 1, 2, etc. So the string sample, it goes A, B, C, D, E, F, G. And if we say string dot, substring dot sample substring of 2, we're just going to get C, F, G. So it's telling us start at position 2. And remember, it's giving us C because, again, starting at position 0. Now, substrings, of course, can also define a stopping point. So instead of, let's saying we don't want to just start at 2, we also want to end at a certain value. If I say like 2, 5 on that same one, you'll see I get C, D, E. Because again, that one is going to have a starting point where we start looking and an ending point. So 2, of course, being C, 3 being D, and 4 is being E. Now, you notice it doesn't hit 5 because it's a stopping point. So it gets that, it doesn't actually print out that 5th character because this is 2, 3, 4, and it stops. All right, so Very important distinction there, knowing how that works. All right, index of. Again, this is where that position is going to come in real handy. If we look at the index of, this is saying, hey, I want just, let's say, a specific word or a specific phrase. I just want to pull the index of a certain piece of that string. Well, this can return the int value of a first occurrence of the substring within it. So let's just say I want a string, and it's hi Mary, and I want to look for where Mary is. Well, that's going to return 3. Now, if I put something that's not in that string, let's say Sally here, notice I get a -1. All right, and that -1 is simply just a placeholder value that says this doesn't exist within the string. All right. We can also ask that same method to look after a certain point in a string. So if we have, let's say, multiple characters to sift through, so let's just say Mary, Mary, quite contrary. You see, we have multiple Marys in here. So if I say index of Mary, comma 0, we get 0, all right, because it's looking right here at, again, position 0. But if I index it of 8, we'll see it returns -1 because, again, it's saying, hey, after this point, there is no more instances of Mary. So it's very helpful for us if we want to be able to sort through these to actually find where those particular things are. Now, you might say at position 8, well, Mary exists, but remember, it's going to start looking here at position 8, and it's not going to actually be able to spell out the word Mary. So very important thing to keep in mind that when you do this one here, the reason why the turn is -1 is because even though it's 0, 1, 2, 3, 4, 5, 6, 7, 8 would be right in here. Notice it doesn't actually spell out the full name Mary, so it would not find that name in there. All right, and our last method to look at, which is last index of. Last index of course, is functioning pretty much the exact same as what we just saw, but instead of starting at the beginning of the string, it simply looks from the end of the string. So exact same functionality as what we just saw, and it's just simply going to return the last occurrence of that substring. So again, if we have say Mary, 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 quite so, and we say last index of Mary, it's going to return 12 because that is going to be where this last Mary comes in. So this can be really helpful if we know we have a long string and we want to look from the other end of it rather than at the beginning. And just remember, again, if you have a value of -1 comes back, that simply just means that that substring that you're looking for within that string was not found. All right, and just a super quick demonstration of some of these methods here. I went ahead and, of course, create a simple string here, and I have a couple methods here to test things out. So I'm just going to go ahead and run this code. And you notice we get, for our length of our string, we get a value of 15. If I say if it is equals, I have I am a string. If I test that against I am another string, you'll notice we get a value of false. If I ask what is the character at position 5, you'll notice we get the value of A. And if we say is it equals to I am a string, you'll notice that these are not equal because here we have a space. If I wanted to, of course, make that equal, I'd have to add a trim in here to go ahead and trim that up, or I'd have to modify one of those two strings that I'm testing with. If I look for the index of am, you'll see we get 2 because 2 would be the position that is right here for am. And if I just print out this in uppercase, again, you'll see it says I am a string. Now, if I wanted to make this permanent, I would have to say my string equals my string dot to uppercase. And then, of course, if I were to print this out again, you will see that if I were to, let's say, remove this line of code here, you'll see that it still functions pretty much exactly the same. Oh, let me just go ahead and take out that to uppercase there, just so we aren't confused with that. You'll see we get the exact same functionality as if we had done that. Except now this is permanently all uppercase. So if we were to run this here with a bunch of these other methods here, we could get some different results because, again, we're now going to have a fully uppercase string. And that, I think, is enough for us to kind of sink our teeth into. There are some other things we're going to get into with strings as we move forward. This was, again, a bit of a longer lesson. And again, it doesn't cover everything in here that pertains to these string methods, because if you see, if I hit this dot button here, you'll see we get this long list of different things that we can do here. So again, we're not covering everything here today, but we have plenty here for us to kind of sink our teeth into and actually get started with being able to code.